Even though there are only 12 numbers on the face of this clock, you can always tell how many minutes have elapsed just by looking at how far the minute hand is between the two numbers. When we look at a digital clock, all it can do is show us, for each digit of the time, the numbers 0 through 9. Even if we zoom in really close, we can't see how close the clock is to flipping to the next digit. So this means the increments of time are fixed to certain digits or levels. Okay. I know you're asking me, how does this all apply to electronics? Let's use this to talk about analog electronics first, so we gotta go back to the analog clock. As the clock's hands sweep across its face, the time displayed is continuously updated with nearly infinite precision. The key here is the continuous change. Analog signals are signals that are continuously variable, or, in other words, continuously changing, just like the time on the clock. As we learned in the video on the difference between AC and DC, the AC voltage in your house continuously changes at a rate of 50 to 60 Hertz. Imagine that we had the ability to stop time and look at the voltage. Okay, I know, bad pun, but what I wanted to show here is that as we move across in time, that the voltage value is constantly changing. This doesn't mean that analog is only found in the wall sockets or through AC, it's just a very good example. In fact, there are sensors, like this accelerometer, which provides an analog output. This sensor varies its output voltage depending on how much acceleration is occurring. If you want to use that analog voltage with a digital system like an Arduino, then you're going to need to convert that signal to digital first. Going back to the digital clock, remember that time can only be represented by a fixed number of symbols like 0 through 9. The same thing is true in digital electronics. The digital signals can only be represented with fixed symbols like 0 and 1. But how do you get those zeros and ones? Well, it turns out that they're formed from voltage. Digital signals can have both a high level and a low level. And so what this means is that at 0 volts, the signal is considered a digital 0, and then at some high voltage, say like 5 volts, the signal is considered a digital 1. As it turns out, digital isn't quite this absolute. Depending on the transistor technology being used, there is a range that the signal might be considered a 0 or 1. For example, on this Arduino Uno, a digital 0 is considered 0 volts up to 0.5 volts, while a digital 1 is anywhere from 3.5 volts up to 5 volts. And so there's these two bands where there's the low and the high. The area between the low and the high is an undefined area. A digital signal with a voltage in this zone could either be considered a 0 or a 1. Because digital logic needs to have a value associated with it, this undefined region will get turned into 1s or 0s. Problem is, we can't always predict which one that they will be. The key to understanding the difference between analog and digital is to remember that analog voltages continuously change, while digital voltages have defined levels. When you step back and think about it, it kind of turns out that digital signals are actually analog signals where the voltage levels have special meaning.
As an analog signal is taken, it may have electrical noise, which makes the signal harder to interpret. Therefore, an analog to digital converter, or ADC, will be used to convert the signal into a digital form. After the signal is converted to a digital format, it will go through a processor that will filter the digital signal. Finally, the digital signal will be reverted back to an analog signal using a digital to analog converter, or DAC. The DAC will reproduce the original analog signal, but the new analog signal will be filtered, which reduces the electrical noise and makes the signal easier to interpret.